Hi everyone, welcome back to chemistry. In this video, we're going to talk about acids and bases, and that's so that we have kind of an understanding of what those are, because we're going to learn about acid-base reactions or neutralization reactions. So we have a couple different ways that we define acids and bases, and those definitions are actually named after different chemists. So the first one, and the only one we're going to talk about in this video, are Arrhenius acids, and we'll talk about Arrhenius bases as well. But Arrhenius acids are named after the Swedish chemist Arrhenius, and he was the first to describe acids as substances that produce hydrogen ions when they dissolve in water. So hydrogen ions, remember, hydrogen's in group 1A, so it's going to lose an electron to become H+. And what's interesting about hydrogen is sometimes you'll see this just written as a proton, because remember, hydrogen is atomic number 1, so it has 1 proton and 1 electron. So when it loses 1 electron, what's left? Yeah, just a proton, right? So it's so sometimes you'll hear H+ hydrogen ions described as a proton. So I just wanted you to be familiar with that vocabulary a little bit. But let's look at this example here. So we've got HCl as a gas being dissolved in water. Remember, HCl is hydrochloric acid. We've worked with it in lab. And writing that H2O above the reaction arrow there means that we're dissolving it in water. Okay, and when we dissolve it in water, we're getting out H+ ions, right, dissolved in water, aqueous, and chlorine or chloride ions, Cl-, also dissolved in water, right? And that H+ is what gives the acid its some of these characteristics. So it's an electrolyte. Arrhenius acids are electrolytes because they produce H+ in water. They have a sour taste. They turn blue litmus paper red. So we'll work with litmus paper in the future. They'll turn it red. And then they corrode some metals. Acids are often corrosive. Right? We've noticed that in our safety data sheets for HCl, hydrochloric acid, before. Okay, so how do we name acids? So acids with a hydrogen ion, H+, and a nonmetal, or like a regular nonmetal or cyanide, it's just one of the exceptions, are named with the prefix hydro and the ending ic acid. So hydro goes in front and ic acid goes at the end. So hydrochloric acid is hydrogen bonded with chlorine, right? Specifically ions, right? Hydrogen ion and chloride, the chlorine ion. And so that's when the acid is just a hydrogen ion and a nonmetal, or cyanide. That's what that one is. Remember, that was one of the ones that you're supposed to memorize. And then acids with a hydrogen ion and a polyatomic ion, except for cyanide, that's kind of a special one. But normally acids with a hydrogen ion and a polyatomic ion are named by changing the end of the name of the polyatomic ion from ATE to ic acid. So if it ends with ate, it goes to ic. So, or ic acid. So chlorate becomes hydrochloric acid. Chlorite goes from ITE to us acid, which is hydrochlorous acid. Okay, you don't need to spend too much time memorizing this. What I really would prefer that you do is you memorize some of the common names or some of the names of some common acids. And this is something that you'll need to know for Gen Chem as well. So definitely just try to start getting it in your brain now, because these you'll see over and over and over again, especially in 163. So hydrofluoric acid, hydrochloric acid, HCl, hydrobromic acid, HBr, hydroiodic acid, HI, and you can see that hydroic acid, hydroic acid, hydroic acid. So you can see that kind of naming structure there. And then we got some of the ones with the polyatomic ions. So that's nitric acid. Remember, it's not hydronitric acid because now we've got a polyatomic ion. So it's nitric acid, sulfuric acid, phosphoric acid, and so on. You can memorize acetic acid if you want to. You'll work with acetic acid in the future too. It's another kind of common one, but it's optional. You don't have to memorize that, but you can if you want to. And sometimes you'll actually see acetic acid written, whoops, CH3COOH, like that. It means the same thing. It's just kind of rearranging those atoms a little bit. Okay, so moving on. So Arrhenius bases. Arrhenius bases produce hydroxide ions, which are OH minus ions, right? That's one of your polyatomic ions you had to memorize when they're dissolved in water. So just like we could dissolve our acid in water and we'd come out with some different ions, when we dissolve our base in water, we come out with well, in this example, when we dissolve NaOH in water, we get Na plus and OH minus. And that OH minus is what is characteristic of Arrhenius bases. So whatever an Arrhenius base is, anything that is going to produce that hydroxide ion when you dissolve it in water. Okay, in this case, our base is sodium hydroxide, and that's a very common base. You'll use it in lab as well. I don't think we've used it yet, but you will use it in a lab in the future. So Arrhenius bases, they taste bitter or chalky. They also are electrolytes because they produce hydroxide ions in water. They feel kind of soapy and slippery. And they turn litmus indicator paper blue instead of red, like an acid. And phenolphthalein, that's what this is, that crazy word there. It's pronounced phenolphthalein. They turn that indicator pink. Okay, and you'll work with phenolphthalein a lot. You'll get very used to working with that one. And those are just indicators that show us when we're in lab, hey, is this product that I have or this solution that I have, is it acidic or basic? Because that does change some of the properties of that solution and how it reacts to things. Okay, so just like we name our acids, we can name bases as well, but these ones are a little bit easier to name in my opinion, because most common Arrhenius bases are named as hydroxide because they all really have that OH in them. So there's sodium hydroxide, which is NaOH. There's KOH, which is potassium hydroxide. There's barium hydroxide, aluminum hydroxide. So in my opinion, those are a little bit easier to remember. I don't see, I thought we had, oh, we don't have a table. So let me go ahead, I'm going to add to your acids table just on the side here, and I'm going to put names of common bases. So these are the bases I want you to memorize. So I want you to memorize LiOH, which is what? Yeah, lithium hydroxide. I want you to memorize NaOH, sodium hydroxide, KOH, which is potassium hydroxide. Sorry, I'm getting a little lazy with my writing here. And then there's calcium hydroxide. Calcium hydroxide. Yeah, so these are the ones on your study guide and the ones that we want you to memorize. And again, you'll use these all the time in Gen Chem as well. So it's not just for this class, you'll use them in the future as well. And sorry, this should actually look more like a capital. There we go. Okay, so that's there for you to memorize as well. All right, so now let's do a quick learning check. So what I want you to do is match the formulas of acids and bases with their names. So HNO2, is that an acid or a base? Yeah, it's an acid. How did we know it was an acid? Yeah, it's got that hydrogen in front, right? And then it's bonded to NO2. What's NO2? That's a polyatomic ion. It's nitrite. So that's going to be D, nitrous acid. Nitrous acid, because we've got NO2 instead of NO3. Nitrite. Nitrite. Okay, CaOH2, what's that? Is that an acid or a base? Yeah, it's a base. It's got that characteristic OH there, okay? So that's a base. What base is it? Yeah, it's calcium hydroxide. So CaOH2, calcium hydroxide, that's E. What about H2SO4? Yeah, another really common acid. So sulfuric acid, B. And again, looking at that hydrogen there, I'm seeing that in front and it's bonded to that SO4. So we got that characteristic H in front. That shows me it's an acid. HiO3, what's that one? Yeah, that's iodic acid, A. And then NaOH? Yeah, sodium hydroxide, C. Again, we got that hydroxide ion there, showing us that that's a base. Okay? All right, I thought there was another learning check, but there isn't, so let's go ahead and end the video there, and I'll see you in the next video.